Chapter 5, we're going to be looking at data. And instead of looking at pictures now, we're going to look at data numerically. We're going to look at data in terms of numbers. And that first number that we're going to be able to calculate is called a measure of center. And that's just it. We're looking at the center of the data, sometimes known as the average. Now, there are actually 3 different measures of center, so there are 3 different averages. So we have to be real careful when we use the word average. The first measure of center, and the most common, is the mean. And how we do that, or what we call that, is the arithmetic average, because we're going to use some arithmetic to find that average. It has a symbol. It's x bar, and that's exactly how we say that. X bar. And if you recall, when it comes from a sample, it's called a statistic. And a statistic does not contain the entire population. So your average, or x bar, might be different than mine if we have different samples. The population mean has a new symbol. It's called mu. It's like an M and a U. It's pronounced mu. And this, if you recall, comes from the population. It's a measure, and so it's known as the parameter. And it does contain all data from the population. So it is consistent. It's always going to be the same value. Now, to calculate both x bar and mu, we need to use arithmetic, i.e. the arithmetic average. To calculate the mean, we're going to use a few math symbols. That's a summation symbol. We're going to sum all my x's, or all my individual observations, and we're going to divide by the total number in my sample, i.e. lowercase n. So again, we're going to find a total, or we're going to sum the observations, and we're going to divide that by the total number of observations. So a calculator would be very nice to have here. So if I look down at this list, these are ages. If I find that total of those observations, it's 277. I'm going to divide that by, if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my arithmetic mean, arithmetic average, is 27 7/10. Now what we need to be careful of here when we calculate the arithmetic average is it's very sensitive. And it's sensitive to extreme values. So if we go back and look at my list, 54 is a little extreme compared to the rest of the values. So what would 54 do? It would make my total higher than maybe it needed to be. So what it's going to do is it's going to shift to the extreme. It's going to shift the value, or my arithmetic mean, to the direction of the extreme. So here it shifted my arithmetic mean toward the 54, or to the right. Another item that we need to recognize about the measure of center, the mean, is that it is a balance point. For instance, if I have these 3 bars and I want to balance, what I would do is I'd slice them off here to build this one up, slice a little bit more to build this one up, so that they would all be the same height. So oftentimes we call it a balance point or a fair share. We're going to share until everybody has about the same amount. So if you look back on these ages, this 54 here got to share a lot with the 19 and the lower 21s, and so they all balanced out to be 27.7. Another measure of center is the median, and if you think about the median, it's the halfway point. Just like the median of the highway is the middle, it's exactly what it is. It's the middle of the data set or the halfway. But what you have to really be careful of here is that data has to be ordered from least to greatest first. Because if your data is in a different order than mine and we both go to the halfway point of the list, we might end up with different numbers. We need to come up with the same value. So looking at this list of data that we had earlier, notice it's not ordered. So if I put it in order, and from this order, all I'm going to do is find the halfway point. So if I go through and search, I'm just going to start knocking these off until I get to the middle. Now the problem is here, I've got 4 and 1, 2, 3, 4. It actually looks like I forgot a 24 in this situation right here. So if I go 1, 2, 3, 4, 1, 2, 3, 4, cancel these two out, there's an even number in my data set. So what falls then between 24 and 25? 24 and a half. So if there's an even number, you average the two to find the median. Now the nice thing about the median is, unlike the mean, it is resistant to extreme values. Meaning this 54 and this 17 both were not counted in my median. They were eliminated out of the list. The mode is the third and final measure of center, and it is the observation that occurs the most often. It's going to occur the most often in a list. The nice thing about a mode here is when I look at my list, I might be able to or have to order it, but if I start looking here, I see 2 24s and I see 2 25s, and that's it. So we might have more than one mode. And in this list I do. I may have no mode at all if it's just a list of numbers and none of them repeat themselves. The mode is really not that useful with quantitative data or numerical. Oftentimes the mode is going to be used for qualitative data. That's what the mode is typically used for. So when I say most of the students at SKC are female, most means mode, and what are they? They're female. Remember, that's categorical or qualitative. So let's kind of just summarize these three measures. The mean is used the most often. It's totaling all my observations and dividing by the number in my set, how many I had in my sample. The median is just that middle number, so it really takes nothing but sorting the data to find it. And the mode is the value that occurs the most often. In the mean, all the scores are used. In the median, not all the scores are used. And in the mode, not all the scores are used. Extreme values, those would be those outliers, the ones that are very large or very small. They affect the mean, but they do not affect the median, nor do they affect the mode. In the existence, you will always have a mean. You will always have a median, but not always a mode. So when are the measurements the most appropriate? If you look, the mean is going to be appropriate when my data is symmetric. The median is going to be appropriate when I have outliers, because it will eliminate those extreme values, and the mode is going to be used when I have qualitative data.